Good morning, all of you. A very good morning, guys. Good morning, everyone. So today I'm going to start a design of steel roof trusses. So actually, I'm supposed to give paper-based, online class. So, but instead of showing the details on paper, so I would like to show you through a presentation, right? So that's the reason why I have started this online class, particularly on this design of steel roof trusses, right? Good morning Anusha, good morning Srinivas. Guys, good morning Kavita. So because let me show you in brief details about types of roof trusses, because instead of just giving you the information on paper, so I thought better to show some pictures of different components of the roof trusses, okay, through the presentation, and how you are going to analyze the roof trusses, and what are the design steps to be followed, right? And what are the formulas based on the IS 875 part 3 to calculate the wind pressure, okay? So based on different coefficients, right? So this is all we are going to discuss today, right? So good morning everyone. Good morning Manideep, good morning Rajesh. So we'll start okay, in 2 minutes, right? So whatever the classes I'm doing, yeah, through online, I'm just uploading in my YouTube channel, so you can just go through again any topic you would like to know, okay, in future. So because by tomorrow I'm going to finish a design of steel structures. So today completely we are going to discuss on concepts and the design fundamentals of roof trusses. Tomorrow we will solve a problem on roof trusses, okay. So by that I am closing the subject, okay. So immediately as per the demand, I'm going to start the strength of materials from Wednesday, I hope, okay. So where it will be useful for AE, AWE and all competitive exams which is related to civil engineering, right? So with the basic fundamentals of engineering mechanics, I'm going to start strength of materials, okay. Hope on from Wednesday, right? Okay, so we'll start with the design of steel roof trusses. So basically, so we go with these kind of roof trusses whenever we required a column free, space. So when the span is more, so when we required a structure which should not have any columns in between, right? Column free structures I can call it as. So the examples I can say like assembly halls, auditoriums, cinema theaters, yeah, airport hangars. So these are all comes under the roof trusses, where you will have a lot of free space without any column in between the structure, okay. So let me start with the roof trusses. So here the trusses are basically in triangular frameworks, so which are consisting of axially loaded members. So as your trusses are made up of with all triangular elements, yeah. So where the members are basically subjected with an axial loaded member. So that is the reason why there will be two major elements. One is strut member, the other one is a tie member, right? So where the forces are acting axially to the member, so where the members are subjected to tension and where the members are subjected to compression, okay. So if you see the bottom chord of the roof truss, it will be subjected to tension based on the axial force acting on it, and the top chords will be subjected to compression, and the members in between the roof truss also will be axially loaded members. So they are more efficient in resisting external forces. So as the cross section of all the members are nearly uniform stressed. See, there won't be, one member will be stressed more and the other member will be stressed less. Not like that. So the whole truss will act as a single unit and the stresses will be uniform, but the magnitude of each member might be vary, okay. So for example, the the strut member and the tie members, their magnitudes may vary, but but the member, it behaves, right? So the uniform, it gonna stress uniformly throughout its length and throat and cross section. So they are extensively used for large spans. So that is a way how we are using this roof trusses for long spans. Okay, guys, can you hear me? So is my voice is audible, everyone? Yeah, John, is it audible, guys? Yeah. uh, So let coming to the applications of the roof trusses. So here the trusses are used for single story industrial buildings and even for the long span floors and for the roofs of multi-storied buildings also. Yeah. And to resist what are the loads which will be carried in the multi-storied buildings, so it gonna resist the gravity loads as well. So here the trusses are all used for walls and horizontal planes of industrial buildings exclusively to resist lateral forces. See, in multi-storied buildings there will be only a gravitational force, so which we called as the dead loads and live loads of the structures. But coming to the industrial buildings where it is exposed to exposed to weather, so it is more exposed to the lateral forces like wind force. So that's why major industrial buildings are supposed to be designed to resist a lateral force and to provide lateral stabilities in the buildings. Okay, so but even for the multi-story buildings, for tall structures, even for skyscrapers, they are supposed to be laterally stable with the help of shear walls. Okay, so the purpose of providing the shear walls to resist your buildings under lateral forces, isn't it? So that is why I mean, it may be the earthquake forces or it may be the wind forces. So in RCC structures you are going to provide the lateral stability in terms of the shear walls, but in the roof trusses, like in industrial buildings, they are going to provide with the help of lateral bracings. Okay, not only on the not only on the a lateral direction of the industrial buildings, even on the rooftop. Okay, so that is how the structure is going to be stabilized. And coming to the analysis of the trusses, so here the truss members are regarded as being pinned joints. So every truss member which is connected at its gusset plate, so I can call it as a joint, is going to be a pinned joint. So why? Because it is supposed to be allowed any allowed rotation. So there won't be any kind of fixed joint in the roof trusses. All joints are pinned. So it allows rotation, okay, in that particular joint. So they are assumed to be jointed together as to transfer what? As we discussed, it's an axial force and not any moments. Okay, not moments and shear forces. There won't be only the axial force. Why? Because in every member, so there will be only an axial force like this. So let us member, so there will be only an axial force like compression force. Okay, or it might be a tensile force like this. So in the roof trusses, no member will be subjected to a lateral force like this. Okay, even though it is subjected to lateral force, the member force will transforms into member in a form of an axial force. Okay, so that is the reason why in roof trusses there will be only a tension member and compression member. There won't be any kind of members which is subjected to moments. Okay, but when you are designing your purlin, I am talking about a purlin which is connecting top chords of the roof trusses. It is supposed to be designed for bending. Okay, so why? Because your purlin is going to support the roof sheeting. Okay, so this is what the roof truss. So in this, your purlin is going to be support the sheeting load. So where the load will be lateral on the beam. So by that you have supposed to be designed your purlin for a moment. Okay, so but coming to the major elements in the roof truss, like strut members and tie members, they are supposed to be designed for an axial loads. Okay, so the loads are assumed to be acting only at the nodes of the trusses. So what do you mean nodes? So these are no nodes. So if you take the roof truss, so node points like this. Okay, and the trusses may be provided over for the single spans, even for the multi supported, I mean simply supported, over the two end supports. So in which case they are usually statically determinate. What do you mean statically determinate? So the analysis done by two things is method of joints and method of sections, isn't it? So through method of joints and method of sections, you can able to analyze the roof trusses and you can able to calculate the magnitude of the force which is acting in the member, right? So here is a statically determinate usually. So where you can able to analyze your structures with the help of equilibrium conditions. Like what do you mean equilibrium conditions? Like you can calculate the internal forces in the members with the help of summation of x is equal to 0, summation of y is equal to 0. These equilibrium conditions you can able to calculate the internal forces acts in the member, right? So these truss members can be analyzed manually by method of joints and method of sections, isn't it? So I think in the first year engineering mechanics you already calculated how to calculate the internal force acts in the member based on its sign. You can decide whether it is a strut member or a tie member. So not only that, there are few computer programs also available to analyze the roof trusses. So you can Google it. So there are a lot of Excel sheets available where you can able to calculate the internal forces in a roof truss members by giving the forces by giving the axial forces which are acting in the member, right? So which are at the node points. So even not only Excel sheet, there are few computer programs also available. So if the time permits, definitely I'm going to share you. Sir, a member said to be compression or tension decided based on external forces or internal forces. See, external force are the member, external force which are going to act on the member. Okay. So based on the external force, you need to calculate the internal resisting forces. That internal resisting forces will be decided whether it is a tensile member or a tension member. Okay. So how you define a truss? How you define a stress? Stress is defined as the internal resisting force to the cross-sectional area of the member, isn't it? So see, when the external force is a tensile force, so definitely internal resisting will be a tensile resistance. So if the external force is a compression force, so definitely the internal resistance will be the compression resistances. Okay, so that is how you are going to decide. So as you told, like it based on the external force, and again it gonna relates with the internal resisting of the member. Okay, that is how you are going to decide whether it is a strut member or a tie member. Okay, okay Rajesh, right? And for the analysis based on pinned joint assumption, so what we can get the axial forces in the different members of the trusses are also can be found. And here the joints are supposed to be bolted, or even it can be connected with the help of a welding, either directly or through large size end gussets. Okay, so there will be a gusset plate. So how your your strut member and tie members are going to be connected to that particular roof trusses. Okay, so there will be gusset plate which is going to be used to connect your different members in the roof truss. So further, some of the members, so which are particularly the chord members. So what do you mean chord members? So chord members are nothing but, so let me show you here. So let us take this as a roof truss. So these are the chord members. So these two are called the top chord members. Okay, so these two are called the top chord members. So this is called as a bottom chord member, right? So here particularly on chord members, so may be continuous over many nodes. So generally such joints enforce not only compatibility of translation in the sense movement, but also compatible of rotation. So why? Because so majorly when it is subjected to lateral forces, your members may translate in the sense movement, and not moment, it's a movement. So but also compatibility of rotation as well. So why? Because when the sections which you are using for the roof trusses are almost unsymmetrical to both the axes, like an angular sections, C sections. So these are the sections are going to be used. So when the sections is unsymmetrical to both either one axis or two axes, there is a possibility of twisting in the member. So where it should be controlled by providing the load not to through the center of gravity, through the shear center. So that is how you can able to control the twisting or rotation of the member, right? So particularly in the main members of the roof trusses, right? So as a result, here the members of the trusses experienced bending moments also. Okay, in addition to axial force. So how? So this may not be, this may not be negligible, particularly at the eave points of pitched roof trusses. So why? Because what do you mean pitched roof trusses? So why? Because your truss is not horizontal, your truss is an inclined way. So by that the force are going to be like wind forces. so which are going to be act as a lateral force on the roof trusses, which are on the top chord members particularly, which are subjected to bending. So when you are designing your member, particularly like this top chords or bottom chords, so it has to be designed not only for the axial force, even for the bending moments also. So here the depth is small and there are large trusses with the members having a smaller slenderness ratio. So as the member is having very less in depth, so it is not subjected to any kind of buckling. So why? Because the depth of the section is almost very less. So here this is the height of the roof truss, which are you are going to calculate based on the pitch of the thing. Pitch is nothing but span with respect to height. Okay, so this height of the on the pitch depth. Okay, so I will explain you what exactly the pitch means to calculate the depth of the roof truss. So here when you are analyzing the top chords of the members, they are supposed to be designed for axial along with the bending moments also, because they are the members which are subjected to lateral forces mainly. And here further the loads may be applied in between the nodes of the trusses, so which has caused bending of the members. Such trusses are referred to as a secondary stresses. Okay, so initial stresses will be the direct stresses. It might be a tensile stress or a compression stress. What are the second are due to the bending moment. Okay, so for the trusses there are two kind of stresses are to be considered. One is a primary stresses, which are called as a normal stress. Normal stress in the sense the way the load is perpendicular to the cross section of the member, so which are going to be considered as the primary stresses, and here the secondary stresses are the bending stresses. And the secondary bending stresses can also be caused by the eccentric at the joint. So why? Because in the roof trusses there will be a possibility of eccentrical loads will be transferred to the node points, so where the bending stresses will cause due to the eccentrical connections. Okay, not exactly by the lateral force, but due to the eccentrical connections your members are be subjected to bending also, as we are going to consider it as a secondary bending stresses. Okay, so further these slenderness ratio of the chord members is greater than 50 and that of the web members is greater than 100 is going to be considered to check whether your member is subjected to buckling or not. Okay, so as I am talking about the chord members, so you hear the top chord members also to be checked for slenderness ratio. So because you can check the member, so as this is the member, you have to check the effective length of the member with respect to the radius of gyration, where you are going to get the slenderness ratio. That slenderness ratio should not be greater than 50. Okay, so it should not be greater than 100 for the web members. So that is how you can able to check the top chord members or even the bottom chord members with respect to its slenderness ratio. Okay, so when they are induced due to application of loads on members, so here there are the possibility of members which are jointed eccentrically as well, so where there is a possibility of secondary stresses due to the eccentrical loads. So here further the secondary stresses due to rigidity of the joints can also be disregarded. So why? Because rigidity doesn't have any kind of secondary stresses. It can be disregarded in the roof trusses when you are analyzing the member for the external forces. So in the case of bridge trusses, particularly due to the high stiffness of the members, so you can able to consider the secondary stresses in terms of fatigue stress of the member. What do you mean fatigue? Fatigue is nothing but reverse slope stresses. Okay, repetitive kind of load in bridges due to the moving load of the vehicles, like it might be either railways or roadways. Okay, so based on the moving load there is a possibility of fatigue loads or fatigue stresses which are acting on the bridge truss members. Okay, so they are supposed to be designed for secondary stresses by considering even the fatigue loads on the members. So here in the bridge trusses, instead of bending moments, here the fatigue loads are going to be considered as the secondary stresses in the bridge trusses. So in MTech, advanced structural design, advanced steel design, you are going to design some bridge trusses also over there, so for bending moment along with the fatigue loads as well. Okay, so here I would like to show you methods to reduce bending moment in the columns. So why? Because we all know that bending moments will be will be more at the center of the section, right? So at the center bending can also be reduced by providing the knee braces at the joints. Okay, so because the load should always be transferred to the supports, isn't it, with some eccentrical force. So that eccentrical force which creates the moment in the columns, okay, at the supports, so it can also be reduced by providing a knee bracings at the joints. So this is how the knee bracing can be provided. So practically also you can see a lot of trusses at joint, like column to truss joint, where the load is transferring with some eccentricity. So here load won't be axial straight away, so the load will be eccentrical. So this is the load and this is eccentrical distance. So with that eccentrical distance, your joint will be subjected to moment. So that moment can be reduced by providing a knee bracing at the joint. So by that you can able to reduce the moment at that particular joints, right? Not only due to the vertical loads, even with the wind loads, right? So before showing the component, so here basically trusses are classified into two types of trusses. One is a braced, unbraced frame truss, right? So braced frame truss, in the sense the truss is completely braced with the help of different ties and strut members. Braced frames, like I can call it as a PEB structures, nothing but pre-engineered building structures, so which are not at all braced within the truss. So by that they are called pre-engineering buildings. So before I show the braced frames and unbraced frames, so which are going to be called as a portal frames, unbraced frames can also be called as a PEBs, and they are also called as a portal frames, right? So they are going to be having a different components. So before showing that, let me show you a video of components of the roof trusses over here. Okay, so let me pause of the presentation and let me show you a video of common elements in the roof trusses. Sorry. Yeah. So here the picture, video, what you are observing is a PEB. So it is unbraced frame structure. So which can also be called as a portal frame structure, right? So this is a bracing which is on the top of the roof truss, right? So which we called as a lateral bracing on the top, and these are the purlins, so which are supporting the top chords of the roof trusses. So where they are supposed to be designed as a beam, okay? And these are all columns. The main column which is supporting the whole span, okay, will be like, you know, tapered sections, and the in between columns will be a normal prismatic sections. So these are the walls, so which are going to be placed in between the columns. So I think when you come across any roof truss construction, so I think you can see all these elements over there. Okay. So there are a lot of components available, Amma. So these are the HVP is also going to be provided over there. So which is like a heat, ventilation and air transformation things also going to be provided for the proper heat transfer, for proper ventilation transfer, for proper light transfers, and there are a lot of openings like window openings for the main door openings. Yeah, and this is how it is going to be constructed. Okay, so it's a completely prefabricated materials, so where it can be erected at site. Okay, so based on the prefabrication drawings, right? So this topmost portion is called as a ridge. Yeah, yeah. So now let me show the presentation. Yeah, so these are the braced frame. So braced frame in the sense, so where your truss will be like this. Okay, so this is the truss, and there are many trusses, so based on the length of your building. Okay, this is the opening of the building, which we called as a vent, right? So bay is nothing but distance between two truss members is called a bay. So the opening of the truss is called as a vent, right? So this is the clearance height, right? And there will be a ridge strut which is exactly at the center of the roof truss, and there will be a roof bracing on the top, and wall bracings also for the lateral wind forces, okay, for the wall. So this, and wall guts also will be there. What do you mean gut? Gut is also a beam. Yeah, PEB is Pennar Industries. So Pennar Industries also you can find the PEB structures over there. And here you can find the guts. So what do you mean gut? Gut is also a beam which is supporting the masonry wall structure. Okay. So here all these beams are supporting the masonry walls. Okay, whatever the beam you are observing here, right? So this is a beam which is supporting the masonry wall of the building. Okay, so this is how the walls are going to be supported with the help of a beam called as a gut, right? So this is the elevation of the roof truss. So you can see this is the span, right? And this is the depth of the roof truss. Okay, and these are the top bracings. So bracings will be provided whole circumference of the building, and these are the columns. So you can see even the top view of the roof truss, so where the top bracings can also be provided. And here one important point where people should remember, if the building is lengthy, right, every fourth or fifth bay is supposed to be braced. So you can see how the fourth or fifth bay is supposed to be braced. What do you mean bay? Bay is nothing but distance between two truss members. So here the bracing was done, and you can see the fifth bay is braced. Okay, so it's all based on the length of the building. Okay, so if the length of the building is long, so definitely it is supposed to be. Some are facing difficulty because of clarity, it seems. Please view it in a high clarity mode so that it will be comfortable. Yeah, so I think clarity is fine, so even in my mobile. So if you are having any, yeah, so if you have any difficulties, as John said, you have to view with high clarity mode, so then only. So I think the presentation was a bit clear. Okay, isn't it? Yeah. So that is how the braced frames elevations and top view looks like. Okay, and further the analysis of roof trusses. Here, as we discussed, the analysis of trusses for secondary moments, and hence the secondary stresses can be carried out by considering your structure as an indeterminate structure. Okay, so for just calculating the axial forces, you can treat your member as a determinate structural analysis with the help of equilibrium conditions. But coming to the indeterminate structural analysis, when there is a secondary stresses like moments or fatigue loads, you have to design your, analyze your structure or trusses based on the indeterminate structure analysis. I think you all know what are the indeterminate methods to analyze the portal frames or even the roof trusses, right? So here, which is called as a pre-engineered building, so which is called as a portal frame, or it can also be called as a unbraced frames, right? So here this is the unbraced frame, right? So you can see the different components of these unbraced frames. Like again, there will be a roof purlin, there will be a ridge, there will be a roof system. The only thing is your truss member will be completely a pre-engineered section. Okay, so it will be an I section, so which is a pre-engineered, and all the sections are a tapered sections. So there won't be any prismatic sections. Why? Because it all based on the member where exactly the more stresses are there, the section will be have more in cross section at that particular point, rest of will be tapered. Okay, so that is how the pre-engineered buildings are going to be an economical buildings for the industrial structures. Okay, so why? Because you can design on your own based on the stresses acting in the particular element. So by that you can redefine the structural element, and you can design that with the help of stress analysis. Okay, so that is how the unbraced frames or portal frames are going to be economical structures nowadays for all industrial buildings. Yeah, so these are the examples of a portal frames. So you can see how the portal frames. So these are called castellated beams under castellated cords under. So because when there is less stresses in the section, so even you can see the voided slabs or voided beams in RCC structures, isn't it? So why they are providing voided? So because to reduce the self weight of the structure. So when you are going with a pre-engineered building, the section will be completely solid I section, solid built up section. So when the solid built up section, in the sense the structure self weight will become more. To reduce the self weight of the structure, you can go with some like castellated beams like this. So where you can avoid section weight over there. Okay, this is how the castellated cords can be provided as a PEB structures, where the structure is going to be economical in terms of its design. Okay. So what are the different types of roof trusses available? So here they are mentioned as three. One is the pitched roof trusses, the other one is a parallel top cut trusses, and the other one is a trapezoidal trusses. So let me show you one by one what do you mean pitched roof truss, parallel chord truss, and trapezoidal truss. So pitched roof truss are the common most types of roof trusses which are going to be designed for industrial buildings. So as whatever the trusses we are seeing regularly in our daily life, they are all pitched roof trusses which are having a slope, okay, within the its length, right? So the top chord is provided with a slope in order to facilitate natural drainage of rainwater. That is what exactly the pitched roof trusses means. And the clearance of clearance of dust snow accumulation can also be reduced by providing your roof with some slope. Okay, so this is what the pitch roof trusses looks like. Where the truss is going to be provided with some slope, right? So the typical span to maximum depth ratio of a pitch roof trusses are in the range of 4 to 8. What do you mean 4? 4 is nothing but 1 by 4 to, so 1 by 8. Okay, so this is the pitch is going to be provided for the roof truss, which is going to be a typical span to maximum depth ratio. Okay, so what do you mean span to depth ratio? Span is nothing but the clearance of the roof truss, and the depth is nothing but depth of the roof truss. Okay, so based on the maximum depth to pitched roof trusses are going to be provided with an economical pitching as 1 by 4 to 1 by 8. So where the larger ratio being economical in the longer spans. Okay, so when your span is more, you have to provide pitch with more ratio. Okay, so that is the reason, that is the way how the pitched roof trusses are going to be provided. For one is for the natural drainage work, and to clearance of the dust or snow accumulation in the on the slope on the rooftop. Okay, and again these trusses have a greater depth at the mid span. So when you are providing with a proper pitch, what happens, the depth of the truss will be more at mid span. So due to this, even though the overall bending effect is larger at the mid span, so by that the top chord members and the web member stresses are smaller closer to the mid span and the larger closer to the supports. So that is the reason why if you see the roof trusses in pitched roof trusses, so what happens at center, your depth of your truss will be more to control the bending action of the complete roof truss in a form of a beam, right? So that's the reason why overall bending effect is larger at the mid span. Okay, that's why your truss is having more depth at the mid span. Okay, so why? Because to control the bending effect in the truss. And the top chord and the web member stresses are smaller closer to the mid span, so definitely, and larger closer to the supports. So if you take the member here, so instead of a prismatic, what happens, it will be larger to the supports, and it will be very less towards center. Okay, so this is how the sections will looks like in a PEBs. Okay, so these are the ones you are going to look at normal roof trusses. So like your sections are going to be tapered in the, even in pitched roof trusses, in PEBs particularly, your sections will be tapered in this form, right? So here you can see the prismatic sections in the normal roof trusses. Okay, so what are the general pitched roof trusses available? So let me show you the pictures over here. So which is the king post truss. So king post truss is nothing but a pitched roof truss. Okay, so which is having a proper slope. So here you can see this is the top chord member. Okay, and these are the diagonal posts. So which might be a tie member, or which might be a strut member. The center portion is called a king post. Okay, so which is called as a center sag member. So we call the center portion of the member is called as a sag tie under the. So why? Because this is the biggest tension member in the roof truss which is subjected to sagging. Okay, so which is subjected to tension. That's why it's called as a sag tie member. And this is the bottom chord. Okay, this is the example. I mean, this is the picture of a king post truss. See, even in your external examination, there will be a theoretical question. What are the different types of roof trusses? They will ask you to draw based on the spans available. Okay, so here the roof trusses are classified based on its classification. So first you have to differentiate based on its pitched roof or parallel top chord truss up trapezoidal truss అని మనం డిసైన్ చేయాలి. So based on that, now I am showing the pictures of the pitched roof trusses. So these are the examples of the pitched roof trusses: king post truss, queen post truss, Pratt truss, French truss, Fink truss. I mean, they are all related to the pitched roof trusses only. Okay, let me show you one by one. So this is the queen post truss. Okay, so generally these king post truss and queen post truss are used for timber structures anamata. Yeah, and these are the different types of pitched roof trusses like Pratt Press. So you can see how the Pratt Press internal members are zero force members. No, internal forces won't be zero force members. Internal forces also will have a internal forces. Okay, internal members also will have an internal forces. That's what why they provide, sir. Which one? Internal members. Internal members are the braced members. See, without providing these internal members, how can you consider your top chord is going to be supported? Okay, your top chord is supported at joint, right? So these joints, so when the force is acting like this, right? So if you want to control the bending in the top chord, definitely your top chord is to be supported with the help of a bracing system, isn't it? So that's why your roof trusses are called as a braced roof trusses underneath. Okay, so like this. Okay, so that is the reason why the main top chord members are going to be supported with the help of number of tie and strut members which are provided in the form of a bracing. Okay, so that's why your roof trusses are called as a braced roof trusses under. Okay, so here the one more important point what you have to consider is, so why we are going with the triangular sections always? Triangular formula enduku veltam sir, why can't it be a rectangle or a square? So why? Because if you consider a internal force in a vertical member or internal force in a horizontal member, internal force in a inclined member. See, this vertical member can only resist a vertical forces. Inclined member can resist only an, sorry, horizontal member can resist only an horizontal force, but inclined members will resist both horizontal and vertical force. So if you resolve this member can be resolved into vertical and horizontal component, where the inclined member can have a resistance towards vertical and horizontal. So that is the reason why all your members will be inclined, which it is in the form of a triangular shape. Zero members in the sense, that's what this internal forces you are going to assess in terms of supporting the main top chord and bottom chord members. Okay, so when your member is resisting on its own, definitely, as you said, the internal forces in the internal members will be zero, but internal members will also have an internal forces. That's what you're going to assess with the help of method of joints and method of sections. Okay, so this is the Pratt truss, and this is how the hoe truss looks like, and this is the Fink truss. Okay, fan truss, Fink fan truss, mansard truss. Okay, so these are all based on the different spans. So here the Fink truss can accommodate of span more than 20 meters. A Pratt truss can accommodate up to 10 meters. So like that, every truss members can accommodate its own span. Okay, so that I will let you know tomorrow in my regular class. So where I will show you the trusses based on its spans. Even in the presentation also it was provided. Okay, so let me show you one small video based on the different types of trusses available. Okay, so just 1 minute. Yeah, so let's see what are the different common roof trusses are available.
trusses are used to support roof covering in conjunction with purlin. They consist of sloping rafters which meet at the ridge, a main tie connecting the feet of the rafters, and internal bracing members.
So these are the basic components.
Shapes. How truss, fink truss, flat truss, gap rail truss, hip truss, house scissors truss, inverted truss, king post truss, mono truss, scissors mono truss, sloping quad flat truss.
Okay, so this is how the trusses are, commonly there. So now let me show you the trusses based on its span classification. So when you can make use of this Pratt truss, when you can make use of this hoe, fink or French trusses. Okay, let me show you with its span. So the first Pratt truss, it is majorly preferable when you are opening, when your span is in between 6 to 30 meters. So it can accommodate without any column in between. Your Pratt truss can accommodate up to 30 meters of its span. So in Pratt Press, the first picture which I showed here, right? So this is the Pratt Press. So in this Pratt Press, it can accommodate spans up to 30 meters as we discussed. So here the Pratt Press web members are arranged in such a way that under gravity load, the longer diagonal members are under tension and the shorter vertical members experience compression. So straight away you can see the longer diagonal members. So here these are the longer diagonal members, isn't it? So in a Pratt truss, the longer diagonal members are straight away subjected to what? Subjected to tension, and the shorter vertical members are subjected to compression in the Pratt truss. So this allows for efficient design. So since the short members are under compression, that is the reason why the Pratt truss can be useful for the spans of 30 meters of length. However, the wind uplift may cause a reversal of stresses in these members and nullify this benefit. So here you can the uplift which happens due to wind within the roof trusses may cause reversal of stresses in these members. So that is going to be a problem in the Pratt truss. So which can be overcome in the other types of trusses. So here there is an hoe truss, so which can accommodate up to span of 6 to 10 meters. So the converse of the Pratt truss you already shown in the picture. So where all members will be majorly members will be in an incline like this. Okay, so yeah, so here the Pratt truss is the most commonly used in light roofing, so that the longer diagonals experience tension and the reversal of stresses due to wind. So here again the longer diagonal members are subjected to tension, and it can be used for light roofing. So light roofing in the sense where the span is less, even the loads on the roofing also will be less. So where you can go with the hoe truss. And next one is fink truss. So up to 10 meters you can make use of this fink truss, so which are used for longer spans having high pitch roof. Okay, so if the span is more than 5-6 meters, up to 10 meters you can make use of this fink truss. So where the pitch is more, and the web members in such trusses are subdivided to obtain shorter members. So like this, all major members will be in horizontal and inclined members. Okay, so this is how the fink truss can be make use up to 10 meters of span. And the fan truss is there, so where it can accommodate of span 10 to 15 meters. So where your fan trusses are subdivided to odd number of panels. Okay, so there are different panels available. Let me show you the fan truss. So this is the fan truss. So what do you mean panel? Panels are nothing but this. This is one panel. This is the second panel. This is the third panel, fourth panel. Okay, fifth panel, sixth panel. Okay, seventh panel. So this is how the fan truss can be divided into different panels, so which is bit advanced than the fink truss. Okay, so that's why it can accommodate 10 to 15 meters of span, opening. And fink fan truss, so the advancements of this fink truss, the the combination of fink and fan truss can be called as a fink fan truss. So where it can accommodate span 20 to 30 meters of its length. Okay, so the more advantages of this is the specific situations, so where it is having plenty panels over there, so where each panel is going to be supported the main top chord members of its length, right? So here you can see on the top of the top chord, you can see the C sections which are acting as a purlins over there, right? So this is a fin fan truss which can accommodate a span of up to 30 meters. And the one more is a mast turned trusses. Again, it can also be used for more spans like 30 meters of its span. The variation of these fin trusses which have shorter leading diagonals. So here the diagonal members are very short, and even in very long span trusses, your unlike the fin and fan trusses can also be seen in the masted trusses. So here the inclined members like this can be very small. Okay, there will be only a few big diagonal members which are subjected to tension, but rest of all are very small members. Okay, so where the members are supposed to be analyzed its internal forces based on its axial force acting in it. Okay, so those are the pitched roof trusses which are available. That's what we are going to study in design of roof trusses as per the BTech syllabus concern. Okay, so let me talk about the economical span. So the economical span lengths of the pitched roof trusses excluding the mansard trusses ranges from 6 meters to 12 meters. So when the span is more, obviously the structure or span is going to be uneconomical, right? So but for 6 meters to 12 meters of spans, you can go with the pitched roof trusses, so where it can be used like a fin truss, fan truss can be used, and the mansard truss can be used in the span ranges from 12 meters to 30 meters, so where it is advanced than the fin fan truss. One second, sorry. Yeah, so more it is advanced than fin fan truss also. So these are the economical spans. You can go with normal fin fan trusses and master trusses where it can accommodate 12 meters to 30 meters. So this is how the economical span can be used for the selection of the roof trusses. And the next one is the parallel chord truss. So what do you mean parallel chord truss? Parallel chord truss in that sense, your top chord and bottom chords are parallel, so there won't be any pitch. Okay, so earlier you have seen all your roof trusses are with some incline. See here, you can see the top chords, so which are with some slope, isn't it? Isn't it? So your top chord member is with some slope, right? So here the other type of truss is parallel chord truss, where your top chord and bottom chords are parallel to each other. Okay, so basically these parallel chord trusses are used for bridges. So you can find like a floor girder. So this is called a floor girder truss, Warren truss, lattice girder, K-type web. Okay, so here the difference is your chords are parallel to each other, right? This one and this one. Okay, yeah. So these are majorly used for bridges. Not only for the bridges, even for launching gantry girders also, these parallel chord trusses are gonna be used. Okay. So here the advantage of this parallel chord trusses is it can accommodate more spans. Okay, so let me show you the more advantages of this parallel chord truss. The parallel chord trusses are used to support north light roof trusses, intermediate span bridges, prefabricated floor joists, beams and girders in multi-storied buildings. Okay, so let me tell you one example. For let us take one roof truss, so which is a pitched roof truss. Okay, yeah, right. So there is another truss like this. Here, to connect these two trusses, the purlin which I am going to use over here, instead of an angular section, instead of an beam sections like I section, C section, I can make use of this parallel chord trusses over here to connect these two truss members to pitch roof truss members with the help of a parallel chord truss members. So this can be used as a truss. Okay, so this purlin can be used as a parallel chord truss like this, so where it can accommodate more spans. Okay, so more bay. What do you mean bay? Bay is nothing but the distance between two roof trusses is called as a bay, isn't it? So ఇది మనం bay అంటున్నాం, అవునా? So when the bay length is more, even the normal angular section, C section and I sections can't be accommodated. Okay, so then you have to go with another truss to connect these main two truss members. So this truss can be used as a parallel top chord trusses which are like this. Okay, so ila మనం trusses ni use చేయొచ్చు. Got it? So you can see these kind of truss systems in temples. Okay, so where there are huge sheds which are constructed with the help of these trusses, right? So there will be two main trusses which are going to be supported with purlin truss, so which are going to be used as a parallel chord trusses over there, right? So that is the best example. And the advantages of parallel chord trusses is the web of the same length, and thus reduce the fabrication costs for very long spans. So when the span is more, you can accommodate this parallel chord truss, as I discussed in the previous this thing. So when the span is more, instead of going with the regular sections, you can go with this kind of parallel chord trusses which can accommodate which can support main two truss members in a bay length. Okay, so that is how it is more advantage. And modified variant is used with additional verticals introduced in order to reduce the unsupported length of compression chord members also. Okay, so this is how. And one more thing, the lattice girders to support the north light trusses can also be used. So what do you mean north light truss? North light truss is nothing but a cantilever kind of truss. So where your truss is somewhat like this. Okay, so to support this north light truss in lateral direction, so this lateral direction, to support this north light truss in lateral direction, you can make use of this parallel chord trusses also. Okay, so that is how these parallel chord trusses are more advantageous. And coming to its economical span, you can make use of this parallel chord truss to a spans of 12 meters to 24 meters of length span to its depth ratio in the range of 12 to 24 meters, right? So the total span is subdivided into number of panels such that the individual panel lengths are appropriate 6 meters to 9 meters for the stinger beams. Okay, so the inclination of the web members are around 45 degrees of an angle, so where it can also be accommodated, right? So what do you mean inclination of the web members? Inclination of the web members in the sense, see, if you see any roof trusses, so these members are called a flange member. The centermost portion is called as a web member. Dine man web antam, right? So the centermost portion of this complete beam like action truss is going to be called as a web, right? So in the case of very deep trusses, it may become necessary to use K and a diamond pattern, K pattern gaani diamond pattern use cheyalsi vastundi. So when there is a huge deep trusses unnappudu, okay, so that is how you can make use of these parallel chord trusses in accommodating these things. And coming to the third one, which is a trapezoidal truss. So this is a third way of truss, which is a trapezoidal truss. In case of very long span pitched roof, trusses having trapezoidal configuration with the depth ends are used. So let me show you how these trapezoidal trusses are going to be. So this is how the trapezoidal trusses are going to be used, where the sections are tapered like this with the help of some trapezoidal shape, right? This is the trapezoidal shape. So that's why these are called trapezoidal trusses. Yeah, so here also you can see. I think now you came to know an information about what do you mean pitched roof trusses. So where your truss is in a triangular shape, the other one is a parallel chord trusses where the chords are parallel in shape, and in trapezoidal trusses your chords are with some trapezoidal action. Okay, even though they are parallel, not exactly parallel, with some varying in its depth, they are in a form of a trapezoidal form, right? So the common types of roof trusses are gonna shown here. So these are the parallel chords roof trusses, these are the trapezoidal trusses, and these are the arch trusses. So even your trusses also will be in a form of an arch action, like bowstring trusses, reverse bow trusses, mansard trusses, like this. Okay, these are the common types of roof trusses which can also be seen in the roof trusses. Okay, like this. So there are plenty so few applications. Coming to the applications for long spans, even for the airport hangars to maintain aeroplanes. It's something like an aeroplane shed. So where they're going to use nowadays all PEB structures. No one are using these kind of regular trusses which are available nowadays. Why? Because you require lot of bracing system for these roof trusses. Then that is the reason why they are going for unbraced portal frames, so which no need to have any bracing systems within the cord members. So that is the reason why nowadays people are going with more economical and more lightweight structures in a form of a PEBs. Okay, so this is another kind of roof types, so where you can find the valley gutter in this shape. I think you can find this kind of structure in where, can you tell me which is where you can find this kind of application? Can anyone? Where you can find this kind of roof type in your real field? Anyone? Please guys. So I think few are viewing, so they can answer where you can see this kind of roof system. So which you're gonna have the valley gutter which is supporting this roof truss, and there is a vertical glazing. Okay, so which is supporting this roof truss, and there will be a glazing also, right? So these are all lattice rafter, and this is a lattice girder. So this is a girder which is supporting this rafter, right? So where you can find this kind of system, ఇది ఎక్కడ మీకు కనిపిస్తుంది రెగ్యులర్ అప్లికేషన్స్ లో? So you can find in railway stations. So if you see your railway station, suspension bridge kadamma, sorry, Srinivas Gaud, it's not a suspension bridge. You can find this kind of roof type systems in your railway station. Okay, so over the platforms, so you can find this kind of roof system where it is going to be supported with a side stanchion. So this is the whole supporting member. So you will have a lattices like this, and this lattice is going to be supported with kind of girder, and again there will be a lattice like this. So that is how the floor level and the rooftop is going to be have in this way. ఓకే, ఎక్కువ మీకు రైల్వే స్టేషన్స్ లో ప్లాట్ఫామ్స్ మీద కనిపిస్తుంటాయి ఇలాంటివి రూఫ్ టైప్స్. సో వెన్ ఎవర్ యూ కెన్ ట్రై టు అబ్జర్వ్ ఓవర్ దేర్. Okay, and there is another kind of valley gutter. So this also will be in this way. It's kind of like umbrella type anamata. So where it can accommodate more column free space, like there will be a big stanchion and the lattice girder will be there, and cantilever trusses will be supported, and each cantilever trusses are going to be supported with the help of a valley gutter like this. Okay, so this also you can see in railway stations, or not even in railway stations, you can see even in big gatherings, big assembly halls you can see. Yeah, exactly, this type using for railway stations, secondary section, exactly. And see, this is the other way of connecting the butterfly type anamata. This also you can see in railway stations. So where this type is called as a butterfly type. చూడమ్మా టైప్స్ చూసుకోండి. దిస్ is called sawtooth type. ఓకే, ఎప్పుడైనా మీరు అబ్జర్వ్ చేసినప్పుడు ప్లీజ్ ట్రై టు నోటిఫై. సో బికాస్ వెన్ ఎవర్ యూ రైట్ రైల్వేస్ ఆర్ఆర్బి ఎగ్జామ్స్ రాసినప్పుడు సమ్ టైమ్స్ దే గోనా గివ్ ద పిక్చర్ అండ్ దే గోనా ఆస్క్ యూ టు ఐడెంటిఫై వాట్ టైప్ ఆఫ్ రూఫ్ సిస్టమ్ ఇట్ ఈస్. So this is called sawtooth type. Okay, so you can see over here, so which is called sawtooth type. So this is called umbrella type, and this is called butterfly type, so which is in a form of a zigzag. So this is called butterfly type roof system. Okay, so these are some of the industrial buildings with the different spans. So these as I am discussing many times, so your industrial buildings are basically classified into two different types of frames. So one is a braced frame, the other one is a unbraced frame. So unbraced frame can also be called as a PEB. PEB stands for pre-engineering buildings. Okay, PEBs. So now we are discussing and designing these kind of braced frames. Manam design chestunna trusses ivanamata, not this. Okay, so if you want to know about the PEBs, you have to go through with the latest textbooks of PEB structures. I don't think even in BTech and MTech of structural engineering, and in BTech civil and MTech structural engineering, no syllabus is having these PEB designs. Okay, I think you have to go through few textbooks, and or else you have to go and learn from the consultants how to design these PEBs. Okay, so but as per the syllabus concern, we are going to design these braced frames. So where your top chord and bottom chords are to be supported with the help of the bracing action. Okay, these are the braced frames. చూడండి the difference మీకు ఇక్కడ అర్థమవుతుంది. So as your cords are supported, these are called based frames, and where here you can see, so only a section will be there in a form of a beam. So these are called unbraced frames, nothing but PEBs. Yeah, sure. I will let you know, Rajesh, what are the textbooks available, or else I can do one thing. I can share you design of a PEB structure manual to you. So where one of my friend is working in a consultancy, where his major designs are under PEBs only. He's very good in PEB design. Okay, I can share that manual to you. So by that you can able to learn about the PEB structures. Okay. So this design is not there as per the syllabus concern, but we are going to design the braced frames. Okay. So these are the regular industrial buildings with the different spans are going to be available, but majorly nowadays in the real applications, so people are using this unbraced frames only. Okay, unbraced frames in the sense it can accommodate more spans and matter, right? Okay, so these are the examples. So this is a braced frame, right? So what type of braced frame it is? So this is called trapezoidal truss, trapezoidal roof truss. So why? Because your top chord and bottom chord are with some trapezoidal shape, kada? So definitely, so that is how the trapezoidal roof truss have seen in the real application. Chusara? So you can see these kind of trusses systems for కోల్డ్ స్టోరేజెస్ కానివ్వండి, లేకపోతే లైక్ కోల్డ్ ఫార్మ్స్ ఉంటాయి కదా, కోల్డ్ ఫార్మ్స్ కానీ వీటన్నిటిలో ఇలాంటి ట్రస్సెస్ ఉంటాయి. వాట్ ఈస్ దిస్? సో దిస్ ఈస్ కాల్డ్ పిచ్డ్ రూఫ్ ట్రస్ కదా. సో వై? బికాస్ యువర్ ట్రస్ ఈజ్ with some pitch, with some slope, right? So by that it is called a pitched roof truss. So again you can see here trapezoidal roof truss in the real application. See how your truss is, how your top chord, this is your top chord, right, is supported with the help of plenty bracings like this. So these are all bracings, right? That's why it is called braced roof system, right? So this is the trapezoidal roof trusses. And here you can see arch roof trusses. See how your arch roof truss is accommodating the span. Enta length undachama idi? So it will be almost, I can say, around 50 meters of length. Definitely it will be more than 50 meters of length. So why? Because your arch action can accommodate such a huge spans and matter. Okay. And again arches also will be under bracing system only. Okay. So where it can accommodate more spans. So here you can see roofed system, PEB structure, right? So PEB, there won't be any bracings in the chord members. So completely it's an section. Chusara? Completely it's an I section and I column. So what is this? So this is called, what is this? So this is called a knee bracing. Okay, మనం already discuss చేసాం కదా. This is called a knee bracing. What do you mean knee bracing? Why? To provide knee bracing to the roof and beam. So knee bracing will reduce the moment at the support. Okay, so this particular support దగ్గర, due to the eccentrical moment, due to the load which is transferring with some eccentricity, this eccentrical moment can be reduced with the help of providing a knee bracing at the joint. Okay, so that is the reason why these knee bracings are provided in the real applications, right? Yeah, so let me explain you what are the different, common types of truss members used in the real applications. So you can make use of angle, T section, circular section, and a hollow rectangular section can be used for light sections to prepare a truss member. Okay, if you want to prepare a truss member, you can make use of angle, T section, circular section, circular hollow pipes, and rectangular hollow pipes can be used for light sections. If you want to go with heavy sections, then you can make use of C sections, okay, I sections for heavy sections, and built up sections for still more heavy sections. Then you can go with two angle sections added together, or two C sections added together, or two I sections which are added together. These are called built up sections. So these are the regular truss members which can be used for light sections, heavy sections, and built up sections. Okay, so please try to remember. So because people gonna ask you in roof truss members, for make your structure economical even for the light loads, which type of truss members can be used? You can go with see, because regularly if you see some canteens or even in your college canteens, your truss members are made up of with circular hollow members only. Why? Because it is more economical. At the same time, hollow circular members will have more resistance towards torsion. Okay, so దానికి lateral stability ఎక్కువగా ఉంటుంది, and hollow circular members never undergo buckling. So why? Because they are more resistant towards torsion. So that is the reason why they use hollow circular members as a roof trusses in a small lightweight structures anamata, right? So like even angular sections can also be used where to frame a small span roof trusses. Okay, so the truss members are lighter loads, heavy loads, and long span bridge trusses. So where we are going to use these built up sections? So these built up sections are going to be used for heavy structures, like heavy in the sense like bridge structures. Built up sections members like built up using I sections, channel sections, angles, and flats can be used for bridges. For heavy loads, heavier rolled sections, I sections, C sections individually can be used. For light loads, you can make use of angle, T sections, hollow circular, hollow rectangles can be used. Okay, yeah. So coming to truss connections, how do you connect your trusses? So what are the connections can be used to connect cords and tie members and strut members at a joint, at a node point? So here the members of trusses can be joined with the help of riveting, which is the permanent connection, bolting, which is the temporary connection, welding again, which is a permanent connection. So here due to involved procedure and high skilled labor required, so nowadays riveting is not commonly used. They are neglecting riveting connection because welding is a permanent connection which they are using nowadays. Riveting, why they are not using, you know, one disadvantage of riveting is it is going to be a permanent connection. The other one is you required a lot of skill to make a rivet connection. Why? Because you have to preheat the rivet, you have to melt that, and you have to use some gunting gens to fit the riveting bolt to the plates. So by that, nowadays because of unavailability of highly skilled labor, so riveting is not commonly used these days, and they are using bolting as a temporary connection and welding as a permanent connection. And again, coming to bolting, they are going to use a high strength friction grip bolt, HSFG bolt, which is made up of HYSD bars. Okay, so why? Because HSFG bolts can be used for dynamic loads, and it can able to resist frictional forces also, where the load transformation takes place through the friction of the bolt. At the same time, HSFG bolts can be tightened to its proof load. So, okay, we can tighten the HSFG bolt up to its proof load, so where it can be pre-tensioned when you tighten the bolt. Okay, that's how friction grip bolts will have more resistance towards shear forces. Okay, at the same time more resistance towards tensile force also. Okay, so in that way HSFG bolts are most commonly used for truss connections in a form of a bolting, right? And again, see the truss connections. Shorter span trusses are usually fabricated in shops and can be completely welded and transported to site as one unit. Okay, they are completely fabricated in the shop itself. And long span trusses can be pre-fabricated in segments by welding in shop. These segments can be assembled at site with the help of bolting or welding. Okay, so that is how short span trusses and long span trusses are commonly transported to the site, right? And the truss connections from a high proportion of the total truss cost. So there will be connection plays a vital role in terms of deciding the truss economy rate. Okay, so trusses may be single plane truss in which the members are connected on the same side of the gusset plates, or a double plane trusses in which the members are connected on both sides of the gusset plates. See what happens if you see the roof truss like this. Okay, so when you are connecting your bracing system like tie members and strut members, so what happens, there will be a gusset plate over here, right, at every joint. So one single plane truss means, so there will be one gusset plate which is connected on this side, so there will be on other side also the plane members will be connected. That is nothing but double plane truss antaru anamata. Okay, so when the members is carrying more lateral forces, more roof loading ankondi, then they're gonna go with the double plane trusses ki veltaru. Ante truss ki on both sides you will have a bracing system anamata. Okay, truss ki both sides, on this face and on the other face. So alaga single plane truss ni double plane trusses ni classify chestar. Okay, so it may not always be possible to design connection with the centroidal axis of the member sections, so which are going to be coincident. So here the small eccentricity may be unavoidable and the gusset plate should be strong enough. As one of the important element in a roof trusses is a gusset plate. Why? Because gusset plate is an element which is going to be connect all different ties and strut members at one point. Okay, so by that gusset plate is the one which is going to transfer the load at its junction. Okay, so by that it will carry more eccentrical loads. By that gusset plates are also to be designed for more eccentrical moments anamata. Okay, so this is how the gusset plate looks like. See how many members are connected to the plate. It can be convinced that this is called a gusset plate, right? So you can see different elements which are connected to the gusset plate, right? So for a single plate, okka plate ke chudandi enni members connect ayi unnayo. So this is called apex connection under dinni. So this is called a support connection. At support here, this is the gusset plate. This is the gusset plate, right? So this is seen in unbraced system and this is seen in a braced system. Okay, so ilanti apex connection అనేది మీకు braced system లో కనిపిస్తాయి. Okay, so this is seen in the braced system and this is a supported connection. You can see only a beam section which is running as a cord and the other section which is running as a bottom cord. So here this is what an eccentrical depth. So this is a gusset plate and this you can see in unbraced system. Unbraced system lo మీ gusset plate ఈ విధంగా ఉంటుంది అన్నమాట. Okay, so this is called unbraced system, right? Okay, so what do you mean gusset plate? So here the size, shape and thickness of the gusset plate is always very important because it's going to depend upon the size of the member which is being jointed, number and size of bolts or length of weld. See, gusset plate is going to decide what should be the length of your joint, what should be the, how many number of bolts are going to be connected and what is the carrying capacity of the member. That all is going to be decided by the gusset plate itself. For making economical joint, your gusset plate should not have more thickness. Your gusset plate should not have more length of the joint. Okay, that is very important. So that is the reason why when your member is having more number of bolts with a more length of joint, so the best option you can go with lug angles. So lug angle is an option where you can reduce the length of the joint, you can reduce the thickness of the gusset plate, you can reduce the number of bolts, where your joint will be more economical. So that is the concept where lug angle comes into picture, where it can able to reduce the different things in the section. The thickness of the gusset is in the range of 8 to 12 meters. You can't go beyond that. Why? Because when the thickness is increases, definitely the cost also going to be increased in the case of roof trusses, and in the case it can be as high as 22 mm in the case of the bridge trusses. Okay, so normally in roof trusses you can go with the gusset thicknesses as 8 to 12 mm. So that is the reason why in problems sometimes if they're not able, if they're not given the thickness of the gusset plate, you can assume in between 8 to 12 mm as in the roof trusses. But in the bridge trusses, as I showed earlier, so this is the support connection where it be used in the bridge trusses. So your thickness of the gusset plate should be 22 mm. So why? Because that is the portion where the load will transferred at the joint or junction or at a node. Okay, so the gusset plate is playing a vital role to connect different truss elements, right? So the design of gussets is usually by thumb rule. So that's what, even if you go through any textbook, so there won't be any specific design for gusset plate. You can find the design of a tension member, you can find a design of a compression member, you can find a design of a cord, you can find a design of a roof truss, but you never find a design of a gusset plate. Why? Because it's just a thumb rule. So how you decide a thumb rule? So here in short span, please try to remember, very important. Okay, so here you have to remember for in short spans 8 to 12 meter roof trusses example, the member forces are smaller, hence the thickness of the gussets are lesser, 6 or 8 mm you can make use of. Okay, so if the spans are more, the length of the roof truss is more, like more than 30 meters, the thickness of the gusset plate, you can go with 12 mm of its thickness. That's it. So why? Because the strength of the gusset plate is always depends on its thickness. Okay, so by that, when your spans are less, you can go with 6 to 8 mm of the gusset plate. When the spans are more, you can go with the thickness of the gusset plate as 12 mm. So this is very, very important. So this is just like a thumb rule. That's what industry fabrication industries usually follow. Okay, even in code there won't be any specification in the designing of the gusset plates. You can just follow the thumb rule like this. Okay, so please try to remember, it will be in the range of 6 to 12 mm, less spans 6 or 8 mm, more spans up to 30 meters, I mean greater than 30 meters, you can go with the 12 mm of the gusset plate thickness. So cross braced lattice wind girder, so this is how which they are going to be used for bridges. Okay, I don't want to focus but much on these lattice wind girder bridges. So this is how the welded connections are going to be done at a joint with the help of a gusset plate. So you can see, right, this is the earlier I have shown you the welded connection, how your section is welded to the gusset plate or directly to the cord member, or you can call it as a rafter. Okay, top cord member can also be called as a rafter. దీన్ని మనం rafter అని కూడా అనొచ్చు, right? So width and length, sir. See, width and length is always depends on the number of elements which you are connecting. Okay, let me show you. Good question, Amma. So మీరు అడిగారు what is the thickness as per the thumb rule. What about the width? See how many members you are connecting here. You are connecting different elements when you are connecting. So the length of the gusset plate is to be taken based on the length of the members. Based on the members you are connecting. So మీరు ఎన్ని మెంబర్స్ అయితే కనెక్ట్ చేస్తున్నారో, సో బేస్డ్ ఆన్ దాట్ యూ క్యాన్ టేక్ ద లెంత్ అండ్ యూ క్యాన్ టేక్ ద width. So that's why if you see your gusset plate in the real application, your gusset plate never have a defined shape. అర్థమవుతుందా? మీకు గసెట్ ప్లేట్ రియల్ అప్లికేషన్స్లో ఎప్పుడు ఒక డెఫినెట్ షేప్ ఉండదు. ఇట్ విల్ బి లైక్ దిస్. జస్ట్ షో మీ. ఇలా ఒక ఇన్రెగ్యులర్ షేప్లో ఉంటుంది అనమాట. ఇన్ దిస్ ఇర్రెగ్యులర్ షేప్ యువర్ మెంబర్స్ ఆర్ గోయింగ్ టు బి కనెక్టెడ్ లైక్ దిస్. అర్థమవుతుందా? ఇలా కనెక్ట్ చేస్తాం. Okay, so here the importance is only the thickness, not the width and length. How to choose a top chord or bottom chord section, sir? See, top chord and bottom chord sections we have to design, amma. Okay, so while designing the roof truss member, I will let you know how to design the top chord and bottom chord member. Why? Because top chord member and bottom chord members are going to be designed based on its internal forces only. Okay, so why? Because as you know, top chord member is like, under compression, bottom chord member will be under tension. Based on the internal forces, you have to design the top chord and bottom chord members. Again, as you said, yeah, based on the length to width ratio, so we have to design that member. So as like a axial loaded member ga design cheyali, right? I think Rajesh, it's clear, right? So the length and width of the gusset plates are going to be decided, the numbers which are going to be connected at that particular joint. Okay, that itself will decide the shape and size of the gusset plate, but the thickness is very, very important. Okay, yeah, so these are the bolted connections and these are the welded connections, right? And the connections of bolted lattice girder, so the lattice girder is going to be bolted like this. So this majorly you can see them in the roof trusses, as a purlin member. Okay, for the long spans you can see there. So this is how the lattice girder can be used as a lateral beams in the buildings. Chusara, right? So earlier when you are designing a beam, so lateral beam we called as a joist, isn't it? So idi girder, right? So this is girder, and the lateral beam we call it as a joist in beams. Beams లో మనం దాన్ని జాయిస్ట్ అంటాం, అవునా? వాట్ జాయిస్ట్? ఇట్ ఈస్ అన్ బీమ్ జాయిస్ట్ అంటాం దాన్ని. ఎస్, సో హియర్ ఆల్సో ఇట్ ఈస్ కాల్డ్ as a joist, but it is with a truss member, right? So this is called open web bar joist అంటారు దీన్ని. So even in the multi-storied buildings or even in long span buildings, you can make use of this kind of steel joist which is acting as a beam, right? So on top of this you can have a roof. Okay, దీనిపైన you can have a roof system. Okay, straight away. So this is how you can make use of even joists to support your girder laterally. Okay, so girder ని lateral గా సపోర్ట్ చేయడానికి మీకు ఈ వెబ్ స్టీల్ జాయిస్ కూడా మనం యూజ్ చేయొచ్చు. ఓకే, yeah, so this is what light roof beams anamata. So with the help of rods you can brace the top chord and bottom chord of the member, right? So instead of going with an inclined members in a triangular shape, so you can find these kind of bracing, okay, this kind of rod bracings in రైల్వే స్టేషన్స్లో మీరు ఎప్పుడైనా అబ్జర్వ్ చేయండి, your roofing was something like which was braced with the help of a rod kada. So ఇది tubal or cords anamata. So this is the rod how it was braced. Even the channel sections are also braced with the help of a solid rods తో brace చేస్తారు. సో ఫర్ లైట్ రూఫ్ బీమ్స్ కి ఇలాంటి స్టీల్ జాయిస్ ని మనం యూజ్ చేయొచ్చు, రైట్? సో దిస్ ఈస్ ద 3-dimensional lattice girder. So where it can be used for launching or it can be used for bridges. Okay, so lattice girders ని మనం ఎక్కువగా యూజ్ చేయొచ్చు ఫర్ లాంగ్ స్పాన్స్ బీమ్స్ కి. లాంగ్ స్పాన్ బీమ్స్ లో ఇన్స్టెడ్ ఆఫ్ ప్రొవైడింగ్ అన్ ఐ సెక్షన్ స్ట్రైట్ అవే యూ కెన్ ప్రొవైడ్ ఏ lattice girder like this instead of a plate girder. So what do you mean plate girder? Plate girder in the sense it is going to be a deep beam which is going to be prepared with the help of web and flanges, isn't it? Right? Instead of a plate girder, the replacement of plate girder is this lattice girder. So you can is based on, yeah, so the 3-dimensional lattice girder can replace your plate girder. Why? Because it can also have the same strength. Okay, the only thing is this lattice girder is going to be economical. Why? Because the sections required will be less compared to an eye girder, right? So ఈ ఐ ప్లేట్ గర్డర్ని మీరు డిజైన్ చేసి అండ్ బై కనెక్టింగ్ వెబ్ వర్టికల్ స్టిఫ్నెస్ అండ్ వెబ్ లాంగిట్యూడినల్ స్టిఫ్నెస్, okay, this all makes your section uneconomical in the sense heavy section అయిపోతుంది. So when you are providing this kind of horizontal longitudinal web stiffness, vertical web stiffness, bearing stiffness to the web, your plate girder is going to become more heavy section. So you can replace this kind of plate girders with the help of a lattice girders, so wherever you require. Okay, so but the what is that the small disadvantage in this lattice girder is head roof. చూసారా మీకు రూఫ్ హెడ్ రూఫ్ ఉంది చూసారా, ఐ మీన్ ఫర్ ఎగ్జాంపుల్ దిస్ ఈజ్ యువర్ ఓపెనింగ్ అనుకోండి, ఇన్ బిల్డింగ్ దిస్ ఈజ్ యువర్ ఓపెనింగ్. ఓకే, సో ద హెడ్ రూఫ్ ఇన్ ద సెన్స్ దిస్ ఈజ్ ద హెడ్ రూఫ్. ఓకే, ఈ రూఫ్ హెడ్ మీకు ఈ లాటిస్ గర్డర్లో ఎక్కువ ఉండదు, సో ఇట్ విల్ బి వెరీ లెస్. బట్ ఇన్ బీమ్స్ యూ క్యాన్ హ్యావ్ ఏ మోర్ రూఫ్ హెడ్ అనమాట. ఓకే, so that is the small difference between the lattice girder and the plate girders. Okay, where it can be useful based on the application you have to go through. Okay, so these are what about the trusses, analysis of the trusses and different types of the trusses. Let's coming to the purlin. What do you mean purlin? Purlin is a beam, okay, which have a bending action about a major axis. So purlins are to be designed for a components like dead load, live load, wind load, which is normal to the axis of the purlin. So this is how purlins are going to be designed. And what do you mean purlin? Purlin is a beam which is going to be support the main two truss top chord members. Okay, so that is how purlins are going to be used, and the loads are acting on the purlin will be the roof load, so which makes your member subjected to dead load, live load and wind load. So by that your purlin is to be designed for moment. So why? Because your load on the purlin will be something like a transverse load, something like a vertical load. Okay, so by that bending about a major axis is due to dead load, live load and wind load, and the bending about a minor axis is due to dead load and normal live loads to the axis of the purlin section. So here the major axis of the your purlin will be designed additional to the wind load, which is normal to the axis of the purlin. What do you mean normal to the axis of the purlin? Let us take this is your purlin. Okay, so one force will be like this, okay, and the other force will be like this. అర్థమవుతుందా? So this force is a normal force. Normal అంటే parallel to the axis of the purlin, and this force is a perpendicular force which is a lateral force to the purlin. అర్థమవుతుందా? So this force makes your member purlin under bending okay, and this force makes your purlin under axial force. So that is how wind forces which are going to be take as a normal axis of the purlin forces, right? And designed in accordance with the requirements of encased beams. So designs as continuous beams with the laterally supported, even the purlins also can be designed as same. So here purlins has to be designed for bending moment, which is calculated based on the plastic analysis. మనం beams design చేసినప్పుడు what analysis we used, the same analysis you can make use of even for the purlin also. So here the purlin is to be designed for a flexural strength, it to be designed for shear strength. So these are the checks we are supposed to do for the purlin, okay? So purlin is to be designed for flexural strength as like a beam, and it should be designed for shear strength as like a beam, okay? So these are the two important checks we have to do for the purlin. So tomorrow while discussing the problems, we will try to solve one problem on the roof truss, and we are going to design a roof truss, and we are going to design a problem on angle purlin, channel purlin and I section purlin. Okay, మూడు purlins కూడా నేను డిజైన్ ప్రాబ్లమ్స్ చేసి చూపిస్తాను tomorrow. Okay, tomorrow time. And see the purlins limitations. So these are limiting deflections. As the purlin is a beam, it should be designed for even serviceability criteria as a limit state concern. So in that point of view, purlins are to be designed checked for deflection also. So these are the deflection limits of the purlin. Span by 150 for elastic cladding with the galvanized iron sheeting, span by 180 for brittle cladding for asbestos sheeting. Very important, Amma. Please try to remember these two important deflection limits. Okay, what do you mean deflection limit? For a beam, you know the deflection formulas, isn't it? A simply supported beam subjected to point load, what is the maximum deflection? WL3 by 48 EI. So that is a deflection, maximum deflection, that is to be checked with the deflection limit. If you go through IS 800 2007 table number 6, okay, so please go through them. Right now I am not having, but I remember the code, page number and table in IS 800 2007 page number 6, table number, sorry, page number I don't know, table number 6, it is giving all the deflection limits based on the serviceability criteria. So as the deflection limits for purlins exclusively based on the lateral forces in the roof trusses. So the deflection limit for elastic cladding with galvanized iron sheeting is 1 by 150 means span by 50, span by 150 anamata. Okay, 1 by 150 ante span by 150 ani ardham. Okay, and for brittle cladding, so with the asbestos sheeting, it will be span by 180. Okay, so these are to be checked. Sir, for purlins, how to decide major and minor axis? See, what do you mean major and minor axis? So whenever your moment of inertia is more towards one axis, that will be the major axis, and when moment of inertia is less towards another axis, that will be the minor axis. That is how you are going to decide. Let us take an angle. If you take an angle of an equal cross section, sorry, equal leg distances, your moment of inertia Ixx is equal to moment of inertia Iyy, isn't it? Okay, yes or no? So if you take an unequal angle, your moment of inertia will be more in one axis, moment of inertia will be less in another axis. So more moment of inertia unnadani major axis andam, less moment of inertia unnadani minor axis andam. Okay, so that is how you can decide the axis based on the sectional property, which is a moment of inertia, right? So that is what about the purlin design. Okay, so those are the loads to be considered for the purlin, and what is the deflection limit per the purlin is given as per the code. Right, now coming to the design of the trusses. So here compression members of the trusses have to be checked for buckling strength about the critical axis of the member. The buckling may be in plane. See, there are a lot of theory in the design of the trusses. I don't want to go with a lot of theory over here. Anyway, tomorrow I am going to solve one problem on the design of trusses. Let me straight away go with that problem where I can explain you better in that direction. Okay, so now instead of reading out all the theory, no need. So here these points I will discuss in the tomorrow class, right? So the design of trusses are going to be like this, and the economy of truss. So one of the important formula where you have to remember is this. Okay, so why how I am going to use this formula in for the tomorrow problem, so you can able to understand here itself. T is equal to 2p plus r. So very important for competitive exams. So this is the economy of trusses. How to decide the economy of the trusses based on its span. So okay, earlier we have seen the span length of the truss is deciding in its economy, right? So when T is equal to 2P plus R, what do you mean T? T is the cost of the truss, P is nothing but cost of purlin, R is nothing but roof covering. Ante economy of truss is always depends on the cost of the purling and type of roof covering, right? So what purlin you are using, so whether you are using an angular purlin or C purlin or I purlin, so based on the purlin cost, your total cost of the truss is going to be decided. Not only that, additional to the roof covering, what are the roof coverings available? You are having GI sheets, galvanized iron sheets, AC sheets, asbestos sheets. Based on the type of roof covering added to twice the cost of purlin will give the economy of the trusses. So this is how to decide the economy of the truss. Very, very important. Please try to remember. So, sir, competitive exams lo ella adugutarante, what are the components used to decide the economy of the trusses? Cost of purlin and cost of roof covering is going to be decide the cost of the truss anamata, right? And so no need to discuss all these the theory, so it will be useful for you. And inputs required for truss design, as how to calculate the wind load. So as I told you, IS 875 part 3 is must and should to design the roof trusses. Why? Because your roof trusses is to be designed for dead load, live load, along with the wind load also. So how to calculate the wind force, what are the different coefficients used for calculating the wind pressure, that all I am going to explain you in another presentation right now. And tomorrow I am going to show you those in your IS 875 part 3, right? So these are the spans and the applications of this building category. So this all I will show you while calculating the wind pressure. Okay, so that ends with the theory, and in the presentation there is one example problem also, how to calculate the wind loading for one example problem. Okay, before discussing about this problem, let me show you how to calculate the wind force, right? So wind force ni ela calculate chestaru, nothing but wind pressure ni ela calculate chestaro ఒక చిన్న ప్రెజెంటేషన్ చూపిస్తాను. Yeah, okay. So wind loading. So I think you are familiar with this IS 875 part 3. Even I'm going to show you the tables which were there in code. Okay, so wind is a very important load is to be considered for tall buildings, even for large opening structures and matter, right? See how wind create lot of disasters to the structures. In reality, the dynamic force is nothing but a wind force. Okay, but for most structures convert, and normally only horizontal load is present in the wind forces. These are key points to design the wind force, right? So if you see the effects of wind on a structure, so this is very, very important. Without understanding this concept of effect of wind in a roof truss, you can't design the roof load. You can't design your wind forces anamata, right? So please try to understand. Let us take a building which is having a rooftop like this. Okay, so due to wind, what happens? This is the wind direction. Due to this wind, so this is the positive wind, so where the wind effect will be more on this surface, and this is the negative wind where wind effect will be very less, which is almost negative here. And this is positive internal pressure which develops inside the building, and there will be uplift wind pressure which will be acted from the downwards direction of the roof truss. Okay, and this is a suction on the roof. సో అందుకే మీకు ఎప్పుడైనా హ్యూజ్ విండ్, ఎక్కువ గాలి వచ్చింది అనుకోండి, సో వాట్ హ్యాపెన్స్, ద రూఫ్ టాప్ విల్ get away from the surface of the roof truss. Yalaga, all your roof sheetings will get away from the roof truss. Why? Because there is lot of suction pressure which develops inside the roof truss, so which makes your roof topping get away from the top of the roof. So that is how the wind effect is going to create lot of disasters to the structures. So by this designing your structure and connecting your roofing system on the top of the roof is very, very important. Okay, so the effect of wind on structure is going to be like this. So earlier you have seen the positive internal pressure which happens inside, and here it is the negative internal pressure also which is going to be developed when opening on downstream side, and here the opening on upstream side. Okay, when there is opening in the upstream side, So the positive internal pressure will develop, and when there is an opening on downstream side where the complete closed on the upstream, so there will be negative internal pressure developed in the structure itself. Okay, and you can see some frictional forces on faces also, so which is going to create the suction out of the plane. Okay, this is also kind of effect takes place due to the wind within the industrial buildings, right? So what are the wind speeds? So here wind speed usually consists of two parts. One is the mean wind speed, other one is fluctuating part. Okay, mean wind speed is nothing but on an average what is the wind force, okay, or wind velocity which is applied on the structure, that is the mean wind speed. The other one is fluctuating part. Fluctuating part in the sense in summer weather, I think in the summer duration you can find a lot of fluctuating wind. Sometimes wind will be very heavy and sometimes wind will be very low. So like that kind of fluctuating wind also will be considered, right? So obtain a mean wind speed from basic values of locating adjusted from altitudes, terrain roughness like sea, forest, city, season for short-term structures only, direction can often be ignored, possibly other factors, cliffs, buildings, etc. So the mean wind speed can be assessed based on the location, based on the basic values anamata. ఏ altitude లో ఉంది మీ బిల్డింగ్ అంటే ఎంత హైట్ లో ఉంది, వాట్ ఇస్ ద టెరైన్ రఫ్నెస్, మీ ఆ ఎగ్జాంపుల్ ఏంది, అది ఫారెస్ట్, సీ కోస్టల్ ఏరియానా ఏంటి, అండ్ యువర్ సీజన్, సో వాట్ ఈస్ ద షార్ట్ టర్మ్ స్ట్రక్చరల్ సీజన్స్ చూసుకోవాలి, డైరెక్షన్ ఆఫ్ ద విండ్ చూసుకోవాలి. దీస్ ఆర్ ఆల్ గోయింగ్ టు డిసైడ్ ద మీన్ విండ్ స్పీడ్ అనమాట. సో వాట్ ఎవర్ ద ఫ్లక్చుయేటింగ్ పార్ట్ విల్ డిసైడ్ బేస్డ్ ఆన్ ద టెరైన్. ఓకే, terrain coefficient అంటారు దాన్ని, based on the sea, forest, city, based on the terrain coefficient your fluctuating part is going to be, okay, considered. And I think this table was there in IS 875 part 3, which gives the velocity of wind at different zones. Okay, so there are around 6 zones in India, right? So where every zones were given with a different colors. So here you can see our Telangana and Andhra is almost falling under this zone. So what is the wind velocity at this zone is given in this color, in the blue, sky blue color kada. In sky blue color lo it was given, I think the value is around 44. So the exact value we will see tomorrow in IS 875 part 3. So where almost your Andhra and Telangana is falling under pink color and blue color. So where you can find the wind velocity over here, okay, from this graph, I mean from the map. So the velocity pressure can be calculated with the design wind speed formula as Vz is equal to Vb of K1, K2, K3. Okay, this is the important formula to calculate the wind speed. Okay, let me explain you one by one what is Vb, what is K1, what is K2 and what is K3. So what is Vb? Vb is nothing but basic wind speed which you are going to get from the map. Okay, ఈ మ్యాప్ నుంచి వచ్చే వాల్యూవే is nothing but Vb, basic wind speed from map. Understood? So please ఈ ఫార్ములా చాలా important for competitive exams. So please try to remember Vz is nothing but design wind speed which is going to be evaluated with multiplication of basic wind speed into different coefficients. ఈ coefficients నే wind coefficients అంటారు. Okay, K1, K2, K3. What is Vb? Basic wind speed you are going to get from the map. Okay, and what is K1? K1 is nothing but risk coefficient. So you are going to get the risk coefficients based on 875 part 3 clause 5.3.1. As I told you, it is in code 875 part 3 in clause 5.3.1 you can find out the risk coefficient K1. What is K2? K2 stands for the terrain height and the structure size factor. How big your structure is, how height your structure is, based on that K2 coefficient can be calculated. And what is K3? K3 stands for the topographic factor. Ardhamavutunda? So topographic factor you will get from 5.3.3. Okay, so please try to go through. K1 is a risk coefficient, K2 is a terrain coefficient, and K3 is a topographic coefficient. Okay, so based on that you can able to get the value of Vz. Vz is a just design wind speed. Then how to calculate the wind pressure? Wind pressure can be calculated with this formula. Pz is equal to 0.6 Vz square. Okay, so let me use the pointer of okay, different color, then I think you can able to see. Okay, yeah, So here you can see the wind pressure formula. Pz is equal to 0.6 Vz square. What is Vz? Vz is the design wind speed. Multiplying square of this with 60% of the thing. So where you are going to get the wind pressure. So this formula also there in clause 5.4 in IS 875 part 3, right? So that is how to calculate the wind speed, I mean wind pressure, okay, based on the wind speed, right? And what is this wind force? How to calculate the wind force? See, you are calculating the wind pressure, and what is this E? A is nothing but surface area of the structural element. And what is CPA and what is CPI? CPA is nothing but coefficient for external pressure and coefficient of internal pressure. Okay, how to calculate CPA and how to calculate CPI were given in clause 6.2.2 and 6.2.3. Tomorrow I am going to solve first problem on wind calculation only, right? So while calculating the wind speed, wind pressure, wind force, so there you can able to understand how I am calculating the CPA values, CPI values, surface area and pressure. Okay, so this is the formula which is used to calculate the wind force. This is the formula which is used to calculate the wind pressure. This is the formula which is used to calculate the wind speed. This will be in terms of meter per second. This will be in terms of Newton per mm square, and this will be in terms of Newton. Okay, this will be in terms of Newton. This will be in terms of Newton per mm square. Why? Because it is a pressure, and it will be in terms of kilometer per second or meter per second, right? So this is how the three different values can be calculated. Competitive exams ki chala important amma ee mood formulas. One is velocity, other one is pressure, other one is force. Okay, understood? Right. So next, see the steps. Obtain for what is the steps to design the wind pressure or wind force or the wind speed. Obtain base wind speed at the location. Calculate the wind, I mean design wind speed. Calculate the design wind pressure. Identify pressure coefficients. Calculate the force. That's it. See, these are the steps you need to follow to calculate the force finally. For calculating the force, you have to calculate CPE and CPI. Okay, CPE, CPI రెండు calculate చేయాలి. For calculating CPA and CPI, you need to calculate the pressure. For calculating the wind pressure, we have to calculate the wind speed. For calculating wind speed, you have to get the wind velocity based on the map. Okay, see, wind velocity, wind speed, pressure, pressure coefficient, force. So these are the steps to be followed for calculating the wind force, right? So you can have an example over here. So I will share you this in YouTube. I mean tomorrow anyway I am going to discuss this problem, amma. So based on this problem you can able to understand how I am going to calculate the wind direction, or I mean wind force. Okay, so here you can find how you are calculating the risk coefficient, how you are calculating the terrain coefficient, how you are calculating the topography coefficient based on the table 1, table 2 and clauses. So this all you are going to get from the tables which are given in IS 875 part 3. Okay, so that code it's already provided. So see, because explaining problem on presentation is not good, amma. So okay, presentation lo problem explain cheste I don't think it will be efficient. So that is the reason why tomorrow while discussing the problem I will try to explain you the whole how to calculate the wind force. Okay, so here I will show you the what we call sir, please explain once again how the internal pressure when walls obstructed. See, internal pressures is due to the suction developed in the pressure. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ చూడండి, రూమ్స్ కంప్లీట్ గా క్లోజ్డ్ ఉందనుకోండి, లోపల మీకు ఒక సఫకేషన్ ఉంటుంది. వాట్ ఈస్ దట్ సఫకేషన్? Suffocation is nothing but some kind of pressure which developed in the wall when it was closed completely, right? So that is how the negative pressure developed in the wall when it is completely closed, even in the rooftop, right? So when the rooftop is something open, then there will be a positive pressure which developed inside the building. Okay, so that is how the pressures developed when there is opening in the rooftop. When the roof is completely closed, there will be a negative pressure developed in the building. Okay, so that is how. Here there is one more problem, how to calculate the wind loading. So here this is the way how I am going to solve problem tomorrow based on the code practice. So okay, so please I request all of you, so please bring your IS 875 part 3 code to the class So while I am discussing and calculating all these external pressure coefficients and internal pressure coefficients based on the code. Okay, so here these are the tables which I am going to get from the code book itself. Okay, so ilaga, I mean, this is the way how we are going to make use of tables from the code, right? So this is the map given in the code, and this is the appendix where it is going to give all the basic wind speeds. If people can't able to observe from the map, you can able to get your wind speeds based on the table. See, you can see Hyderabad is having a wind speed of 44 meter per second. Okay, so this is our zone. I think Hyderabad falls under 4th zone. Okay, so where the wind speed in Hyderabad is 44 meter per second. It is a normal wind speed, right? So like this for different places in India, so the wind speeds are given. Okay, so these are the tables. Table 1 which gives the risk coefficient, table 2 which gives the terrain coefficient. Okay, so table 3, I mean category 3 which gives the terrain coefficient, and table 2 which gives the topographical coefficients. Okay, terrain and height multiplication factors. ఈ టేబుల్స్ అన్ని 875 part 3 లో చాలా క్లియర్ గా ఉంటాయి. సో టుమారో while explaining the problem I will explain you those things. Okay, so this is how you are going to calculate all these wind force calculations. Okay, topographic factor K3 ఎలా calculate చేస్తాం, right? Everything I will explain you tomorrow, no worries. Okay, so these are the tables which you required to calculate the external pressure coefficients and internal pressure coefficients in the roof trusses. Okay, roof trusses లో internal pressure coefficient, external pressure coefficients ఎలా calculate చేస్తారు for calculating the wind force. Okay, that we will get from this tables which was given in the code, right? ఇవన్నీ కోడ్ లో నేను ఎక్స్ప్లెయిన్ చేస్తాను టుమారో. ఓకే, అండ్ ఇన్ ద ప్రెజెంటేషన్ దెర్ ఇస్ వన్ మోర్ ప్రాబ్లమ్ ఆన్ ద ఇండస్ట్రియల్ బిల్డింగ్, హౌ టు డిజైన్ ద కంప్లీట్ రూఫ్ ట్రస్ ఆల్సో ఇట్ వాస్ గివెన్. Okay, so I will share anyway this problem also in the presentation. So first you are going to calculate the wind force, then you can able to calculate the internal pressure coefficients, and then you can able to calculate the design of the roof truss completely. Okay, so how the typical roof truss parameters are going to be selected, how to design the roof trusses, everything it was shown in the presentation, right? So this is how the importance of the roof truss and the design of the roof truss is explained clearly for the today's class. So tomorrow I gonna solve few problems, one on the wind and the other on the design of a roof truss. Okay, and the time permits, then we will start designing on the purlin also. We will solve 3 purlins. One is angle purlin, channel purlin and I section purlin, because you may come across any problem in your examination. Okay, so that is the reason why. So we will do problems tomorrow, right? Yeah, that's it guys. So that ends with the presentation today, right? So thank you so much for spending your time and your valuable time. So let me come tomorrow with the design of roof truss problems. Okay, okay guys, so any doubts, so feel free to question me through Facebook. I will upload this presentation in YouTube channel Vamsi Krishna Basava, so by that you can go through once again also, right? So please feel free to question me any doubts related to roof truss designs and concepts of the roof trusses, right? Okay guys, thank you so much.